Everyone, welcome to the practical session of Channel of Mama Physics. It's current about potentiometer. Current electricity can involve potentiometer or meter bridge. There are differences between potentiometer and meter bridge. The meter bridge has gaps, but potentiometer does not have gaps. Also, if you don't have the potentiometer, you can use the meter bridge, but you neglect these gaps. You use just this place here, that has the wire, and these two nodes. The aim of this experiment is to determine the resistivity of wire W provided. Proceed as follows. This is our circuit. This is our point A. This is our point B. From A, the wires are connected to the battery. That's the positive terminal of the battery. Then the positive terminal of the battery goes to the switch. Then to the resistance box. Then galvanometer. Then galvanometer is connected to the jockey. Then from the jockey, then here is our point B of the potentiometer, which is connected to switch K2. This one here is K1. This one here is cell 1. Then from K2 to cell 2. This here is all what's called a complete circuit. Steps. Connect the dry cell E1 in series with 50 centimeter of the wire provided. Here is the wire which we are provided. This is wire W. The resistance box R here. And switch K1, this one here. Complete the potentiometer circuit by connecting two dry cell labeled E2. Here is our E2, cell 2. E2 in series with potentiometer wire AB. Here is our A, here is our B, AB. And switch K2. This one is switch K2. Connect the galvanometer G and jockey. Here is our galvanometer, and this one here is our jockey, as shown in the circuit. Then obtain the balanced length L corresponding to the potential difference across the wire W, where R is at 6 ohm. So we have to set at our resistance box the resistance of 6 ohm. Initially here, we were having all these nodes closed, but our question needs only 6 ohm. So here we remove the 5 ohm and the 1 ohm, that makes a total of 6 ohm. Then you obtain the balanced length by using the jockey. I said here is our A, here is our B. So we obtain our length by starting moving from A to B as follows. While finding the balanced length, you should not scratch the wire. You should just move gently to avoid the resistance and the heating effect of the current. So you go gently. Here is our galvanometer. You go gently, finding the balancing length. Gently, you go gently. You go gently. You go gently. The balanced length will show us at a place where our G, this arrow points to 0. So we go finding our balancing point. Wait, let's start again. Finding our balancing line. When we put here 6 ohm, will be at 31. Then after getting 31, you write your length. Then what follows is when ohm is 5 only. So we remove only the node of 5. Then we find the balancing point, which will be at 34. Then when ohm is 4, point will be at 39. Then when we find a balancing point, which will be at 45. Then when ohm equals to 2, find a balancing point, which will be at 51. Then when ohm equals to 1, then we find our balancing point, to be at when the length equals to 60. After getting your data, you tabulate your results for L, R, and 1 over L. Here, it's R column, L column, 1 over L column, of which you get by using your own calculator. So here, 1 over L is 0.032. 1 over 34 is 0.029. 1 over 39 is 0.026. 1 over 45 is 0.0222. 1 over 51 is 0.0196. 1 over 60 is 0.0167. After getting your data collected, you plot a graph of 1 over L against R. 1 over L will be in the vertical axis, R will be in the horizontal axis. Then you determine the resistance of wire W. The resistance of the wire is given by 1 over L equals to K over E1 RWR plus K over E1, where K is the potential drop per centimeter along the potential wire AB. Then you measure the diameter of the wire using a micrometer screw gauge. Here is our micrometer screw gauge. .38 millimeter. Then you determine the resistivity of the wire W. Then after that, state any two sources of errors and precautions taken in this experiment.
Okay, after finishing our experiment, we collected data and recorded in the table of results, where we have resistance in ohms 1 to 6, the length of the wire W in centimeter, the reciprocal of length in centimeter inverse. Okay, the theory behind the practical. From the theory of V equals to I, R, voltage equals to current times resistance. Also, voltage equals to K times L, where K is the potential drop per length. Thus, IR equals to KL. Call it equation number 1. Also, voltage across wire W equals to I times resistance of the wire, but also equals to KL. Therefore, current times resistance of the wire equals to KL. Call it equation number 2. But EMF of the cell equals to I times total of the resistance in the circuit, which involves internal resistance plus resistance from the resistance box plus resistance of the wire. But we take the assumption where we neglect the internal resistance R. Therefore, making I the subject to be equals to EMF over resistance from the resistance box plus resistance of the wire W. Then we call it equation number 3. Substituting equation 3 into equation 2. So it will be, in place of I, we put E EMF over resistance plus resistance of the wire. So it will be E over resistance plus resistance from the resistance of the wire W times resistance of wire W equals to KL. We open the brackets to be EMF times resistance of wire W over resistance of the resistance box plus resistance of the wire W equals to KL. Then we reciprocate to be resistance plus resistance from the wire W over EMF times resistance of wire W equals to 1 over KL. We multiply by K both sides. It will be K brackets resistance plus resistance of wire W over EMF times resistance of wire W equals to K will cancel. So 1 over L equals to KR over EMF times resistance of YW plus K times resistance of YW over EMF times resistance of YW. This and this will cancel. We get the equation 1 over L equals to K over E RW times R plus K over E, which is the same as Y equals to MX plus C. Okay, from the question we are told to draw the graph of reciprocal of length against resistance R. Here is our graph where the y-axis is the reciprocal of length and the x-axis is resistance in ohms. I'll see the graph is a straight line crossing the y-axis and the x-axis. Here's the triangle for solving the slope of the graph. The scale, where the horizontal scale 1 centimeter represents 1 ohm, vertical scale 1 centimeter represents 0.02 centimeter per negative 1. So from the graph drawn, we find the slope, which will be equals to change in 1 over length over change in resistance, which equals to 0.03 minus 0.024 over 5 minus 3.3. The units are centimeter per negative 1 per ohm. So the slope, we get 3.5 times 10 per negative 3 centimeter per negative 1 ohm per negative 1. Then from our equation here, y equals to mx plus c. Thus the y-intercept from the graph equals to k over e. Y-intercept equals to k over e. E is the EMF of the cell, which is 1.5. Y-intercept we read from our graph, which y-intercept equals to 0.015 centimeter per negative 1. Therefore, k over e, which is 1.5, equals to 0.015. K will be equals to 1.5 times 0.015 centimeter inverse. K equals to 0.0225 centimeter per negative 1. Okay, after getting K, which is the potential drop, we go back to our equation where the slope equals to K over EMF times the resistance of the wire. K we have, EMF of the cell is 1.5, the slope we have, hence we can get the resistance of the wire. So, slope will be equals to K over E times resistance of the wire. Thus, resistance of the wire will be equals to slope times E over K. The slope is 3.5. Okay. Here we used EMF of the cell 1.5 because the cell was known, but in your practical experiments you do not know the EMF of the cell. So from here we'll take that K over E is equal to y-intercept. So you say that slope equals to y-intercept over the resistance of the wire. So to get the resistance of the wire to be y-intercept, which is 0.015 over slope, which is 3.5 times 10 power negative 3 we'll get the resistance of the wire equals to 4.3 ohms. Then lastly, to find the resistivity, from resistivity equals to resistance of wire W times area over length. Area equals to pi d square over 4. The diameter of the wire, as shown in the experiment, we measure it using a micrometer screw gauge, equals to 0.37 millimeter. So to get area, it will be pi times 0.37, but here we're using meters, which would be 0.37 times 10 power negative 3 over length over 4. So the area, we get it is 1.075 times 10 power negative 7 meter square. Then going back, we say resistivity equals to resistance of the wire, which is 4.3 ohms, times area 1.075 times 10 power negative 7 meter square over length, which is 0.5 meter. So resistivity will be equals to 9.2 times 10 power negative 7 ohm meter. Okay, after finishing getting the resistivity of the wire, there are some sources of errors in this experiment. First include the parallax error in reading the readings from the galvanometer, in reading the point on the potentiometer, also in the deflection and measuring of the diameter using the micrometer screw gauge. It can cause error in your experiment. The second cause of error is graphing error. In plotting your graph, you can mistake the pointing of the point on the graph. Also, in marking the points which you use for finding slope, you can get errors from there. The last one is polarization of the cell. During the experiment, we used a key which is connected to the circuit. So if you forget to remove the key, and the circuit will continue flowing with current all the time, it can cause error in your experiment. To prevent those errors, first the key should be removed when you're done recording, so that to prevent continuous flow of current in the circuit. Second, to reduce parallax error, you should stay at the right position when taking readings from the galvanometer, when measuring the diameter of the wire, and when recording the point on the potentiometer. And lastly, the graph should be well drawn so as to obtain the best line properly, and the points should be properly allocated. Thank you for watching. Welcome again to channel of Mama Physics. Don't forget to like, subscribe, and share.